Okay, so we're on part 2 of my adventures in nickel plating, and today what we're going to do is actually hopefully use it for the whole reason I wanted to be able to do this process in the first place. And that is, we're going to attempt to re-nickel plate some parts from this lovely Jensen Model 70 steam engine that I restored recently. And the parts that we're going to attempt to replate are here. I'll close in on those so you can have a look. So we've got the safety valve, the whistle, the 2 bolts that hold the sight glass block in, and the protection plate that goes on the top. And as you can see that these are, all the nickel plates come off of these completely. There's a little bit left on the whistle, but not much. But these are basically down to bare brass. Now I've given them another going over with the wire brush. I shall wipe them off with acetone before we attempt to do this. But this is the main object today, is to get these items nickel plated. I also thought, as we've got it all out and going, that we would try the whole process on some different metals. Now, so here we've got, this is a piece of mild steel, this is stainless steel, this is cast iron, this is copper, and this was a great suggestion from my good friend Rob over on the Zanudo YouTube channel. He said, how do you think it would work on 2 dissimilar metals? So I decided, his suggestion, to get 2 bits of mild steel which I've brazed together. So that's bronze brazing there. So we'll try that and see whether the nickel plate will go over both the mild steel parts and the brazed part. And then also, just for a laugh, we've got a bit of aluminium. Now, from what I've read, you need to expose the aluminium to another process before you attempt to nickel plate it, but I thought, what the hell, we'll try it anyway just to see whether anything happens. So yeah, we're going to do the parts from the steam engine and these attempt to do these various different metals. We're going to start with the steam engine bits. So it's all ready to go. This has been warmed up. It's not as warm as it was when we first made the solution, but it is warm. So we're going to try, initially, we're going to try something easy, like this, like the guard plate for the sight glass. So we'll turn on our power, which we've got set to 4.5 volts. I'll close in on the solution so you can see what it's actually doing. We're ready to go. So this is brass, and this is the sight glass protection thing. Oh, and it's bubbling away already. That's good news. And obviously I'm going to have to take it out and move the crock clip, because I obviously want this thing nickel plated all over, not just on, and that includes the bit that's underneath the crock clip. So quite a vigorous reaction. Oh yeah, lovely. That seems to be working quite well. Well, leave it in because we want a decent coat of plate on there, I think. Yeah, nice. We'll leave that in there for a few minutes, and I'll come back once I'm happy with the level of plating. That's probably been in there total time 2 minutes maybe. There's a couple of areas where it's not quite plated properly, but overall, no, that's not too bad at all. So we'll pick the next thing. So next up's the whistle. We'll stick that in and see how, because we may well have to move the crock clip round onto this, because this bit obviously rotates inside the whistle body, but we'll give it a go. Quite sure how well you can see that, but let's close in a bit. It is definitely fizzing away quite nicely. Current, we've got 4.5 volts as is the recommended optimum, and the current's about 0.7 of an amp. Yeah, that's coming along okay. It does look like we are going to have to put the crock clip onto the other part of it, which I'm not surprised. It's probably very poor conductivity through the valve of the whistle, as it's only a sliding fit in the whistle body. Well, the whistle's come out really well. I left it in there for about 5 minutes. I did move the crock clip round to the valve arm just to make sure that it was all fully coated and everything, but no, that's a massive difference. That's just pretty much as it should be. I'm going to try one of the sight glass blocks now. It's quite impressive. I mean, you know, it's been in what, 30 seconds so far. If I pull it out, there is already nickel plating on there, and that's just 30 seconds. But we'll leave that in again. I'll probably leave it in for about 5 minutes. I want a good coating. I'll come back when it's done. So there you go. It's done a damn good job on that. I'll put it down on the bench next to the other one, which I haven't done yet, as a good, so you can see the comparison. This is the one I've just plated. This is the one I haven't touched yet. I think you can see quite clearly that there's a really good coating of nickel on this one, and this one is still brass. So yeah, the process works really well. I'll get on and do the rest of the steam engine bits. There's no point in me showing you. There's only the other block, this block to do, and the two retaining screws. I'll do those off camera, and then we'll come back when that's all done and we can have a close look at it. Right, all the steam engine parts are done, and I am well pleased. They've come out really well. They're not perfect. There are some places where it's not, the plating hasn't gone so well. You can probably see it here. A little bit of discoloration there. And on the back of the guard, it hasn't gone quite so well. But I'm think that that's probably more due to lack of good cleaning first off on my part than the actual solution not, you know, doing its job, because, you know, there's a very little brass now showing on any of these items. They are, I mean, the whistle particularly has come out very well. I'm well pleased with that. That is now a nickel plated whistle, which is exactly how it's supposed to be. Same for the safety valve, again, nice and nickely now. So I'm going to count that as a success on the model steam engine parts. Right, let's move on to the other strange metals. So there we go, and as I said, we have mild steel, stainless steel, cast iron, copper, 2 bits of mild steel with bronze brazing on, and the aluminium, which of course we don't expect to work because, as I said, that apparently requires another process. But we'll start with the mild steel. Now my intention with these is not to coat the whole thing, so I'm only going to have like half of it in the liquid, so we can clearly see whether there's been any plating going on by comparing it to the bit that's not in the plating solution. So we're in there. Let's turn the power on and see what happens. Let's close in on that a bit, see whether there's any. I can see some bubbling. Yes, now interestingly, this is the mild steel, and the current draw is about the same as it was with the brass bits from the steam engine that I put in there, but the bubbling is not as vigorous, not to my eye anyway. Maybe, I mean, you could probably see better than I can, than it was with the brass. So, well, we'll give it 5 minutes, and we'll come back and see whether there's been any plating going on. Well, our 5 minutes is up, so let's take it out of the solution. Right, well, there you go. I don't know how well you can see that, but there is a definite line here where this part was out of the solution. This bit was out of the solution, and this is the part that's within the solution. So yeah, there's a definite coating of nickel on the steel, and it's quite nice. This is you know, I mean, obviously I brushed the wire, I brushed this to clean it up, and then you acetone on it. But I did all the brass bits as well. But I reckon that's very nice. It's a very definite coating on there. That's obviously worked quite well. Next up, the stainless steel. Now I'm not really sure how well this would show up even if it did get coated, because obviously the stainless is quite shiny and bright. But I'll put it in halfway, so hopefully we can see a line on it when you know, when it's done. Right, stainless is in there. Turn the power on. Yes, it's bubbling. Not drawing as much current as the mild steel was. The mild steel, I think, was about 0.5 of an amp, much like the brass was. This is drawing 0.35 of an amp. Let's swing you round so that you can see the power supply. It's going up 0.36 now, but that's definitely quite a much lower starting current than the brass or the mild steel. But well, you know, something's definitely happening. It's definitely it's definitely bubbling, but it's nowhere near as vigorous as either of the other two metals, so that's interesting. So that's stainless, so we'll give that 5 minutes and we'll come back. This is actually a little bit over 5 minutes, probably more like 8 minutes, but we'll fish it out. There we go. Well, I can see a definite, I don't know whether you guys can see it, but I can see a definite line on there. In fact, the plated area doesn't quite look as shiny as the actual stainless does. You can see that line there right in the middle. So yeah, I think that's worked. I think we've got plating on there. So we'll have a good close look at these when I've done them all. Okay, now we're going to try the cast iron. And again, I'll put it in halfway so that we've got some comparison. Turning it on. Okay, this time it's drawing about 0.36 of an amp. And it's bubbling. And you can see that. It's already bubbling. And yeah, I would say, again, similar to the stainless and the mild steel. Not as vigorous as the brass, but then we're not drawing as much current, so that might explain the lack of lots of bubbles. But yeah, it's definitely doing something. So as you can see, I've got it in about halfway, so we'll be able to make a good comparison with it. Right, I'll leave that one in 4 or 5 minutes, and I'll bring you back. We'll turn the power off, and we'll drag it out. Let me just dry it off a bit, and there we go. Again, I think you can see the clear line on there where it was in the solution and where it wasn't, and there is quite a nice coating of nickel on that piece of cast iron. So another success. Next up, copper. And I'm kind of expecting that to draw a reasonable amount of current, because obviously copper is a massively good conductor. So, and again, I'll put half of it in so that we've got a good comparison to make. Copper's ready to go, turning the power on now. Well, that's interesting. It's only drawing about 0.24 of an amp. I'll swing you around so you can have a look at the power supply. Now, maybe because it's such a small bit of copper, I mean, that may make the difference. Surface area, I honestly don't know. I don't fully understand. You know, I know that what's going on. I mean, I know that the nickel ions in the solution are being deposited onto the copper anode, but amount of current that's drawn through the solution does vary quite dramatically. So let's have a look at that from a different angle. You know, that to me is more vigorously bubbling than the previous metals, much more akin to the brass when we put the brass in. So oh well, We'll give it 5 minutes just like the others, and we'll pull it out and see what the results are. Right, the copper's been in there for, it will be just coming up to 5 minutes. So we'll whip that out and have a look at that. One thing I wanted to say was that you're seeing this in real time. I haven't done all these tests already and know what's happening. This is literally the first time I've done these tests, so I don't know any more than you guys do what's going to happen when I pull this stuff out of the solution. So it's not, this isn't like just been done for the camera. This is actually me doing it for the first time, and these are the results we're getting. Okay, let's pull the copper out. I'll turn the power off. That was a good idea. Yes, well, lovely, an absolutely lovely nickel coating on there. You can see that quite clearly. Looks a bit like a Duracell battery, doesn't it? A AAA battery. Lovely. It's done a good job. I mean, so this is a bit of copper tube, so I don't know whether the inside has been done, but I'll have a closer look at that later. But yeah, no, that's great. Next up, the one that was Rob over on the Zanudu channel's suggestion, which is 2 bits of mild steel brazed together. Now, I've cleaned this up on the wire brush and I've done the old acetone wipe over it as well. I guess that these will both metals will plate fine, because we've tried it on brass and that plate's fine, and we've tried it on mild steel and that plate's fine. So yeah, I'm hoping that the nickel will coat both of those. So we'll see. It's in the solution. Power's going on. And off we go. Well, that looks to me like it's bubbling on both metals, the bronze and the mild steel. The bronze braze, that's got bubbles all over it, as has the mild steel. Current's at 0.43 of an amp, so it's certainly a bit more than the bit of copper tube. But not quite up to the level we were with the mild steel. Right, come back in 5 minutes. 5 minutes is up, and it's time to pull out our brazed parts. So bear with me, I'm going to have to move the camera out of the way. Turn the power off. Oh yeah, just wipe that off a bit. Well, you can see that, but that would appear to have nickel plated both the bronze brazing and the 2 mild steel parts. You can see the line there where it was out of the solution, equally as well. So we'll have a closer look at that when we've done them all. But yeah, that looks pretty damn good to me. So hope that answers your question, Rob. And finally, just for a laugh, we're going to do the aluminium. I don't expect this to do anything at all, because, as I said, as far as I understand, you need to put it through another process before you can actually nickel plate it. But what the hell? It's all here. The setup's all here. We might as well give it a go. Power on. Well, that's interesting. Let's close in on that a bit for you. We are getting some bubbling. I didn't really think there was anything was going to happen, but it's drawn about 0.43 of an amp. So yeah, I mean, it still may not do anything, but there is a reaction going on there. So we'll give it the standard 5 minutes and come back. Right, 5 minutes is up. Turn the power off, and we'll pull the aluminium out of the solution. Well, I don't know how much you can, how well you can see that, but there's a definite line across there where where it was in the solution, and there's still a definite line on the back. It's not quite as pronounced, but it's definitely a line there. So I don't know. I mean, it's definitely changed. The aluminium's changed colour. You can see that quite clearly. So we'll have a closer look at it. So there are our test metals. Now, I've turned the lights away a little bit to try and get a good contrast between the different the different metals and how they've responded to the plating solution, and we'll go through them one by one. The mild steel, first one we did, can quite clearly see that it has a lovely coating of nickel here and nothing here, where it was out of the solution. These marks, by the way, were jaw marks. They were already on the piece of test piece, but yeah, it's done a good coat on the end all round, and yeah, very pleased. That was 5 minutes. Now obviously I haven't tried polishing it or anything, so I don't know how well that's going to stand up to cleaning or anything, but to my mind that's a lovely result. Mild steel. Now the stainless, well, you can definitely see the line. The duller part is the nickel plate, that's the stainless at the top, and you know, it's definitely put some plate down. It's just that it's not so easy to see on the stainless because it's so shiny in the first place. But yeah, it works. It's definitely plated it. I'm not really sure why you want to plate stainless steel with nickel necessarily, but I mean, I guess if you had a model steam engine that was mainly nickel plated and it had you had to make a replacement part in stainless or something, you might want to do that. But it works. That's the important thing. So that's stainless. Cast iron. Yes, did a lovely job on the cast iron. I think you can quite clearly see the line. That's cast iron, and that's nickel plated cast iron. It did an absolutely superb job on that. I wouldn't have any qualms about using this process to nickel plate cast iron. Lovely job it did on that. Lovely. And again, the copper. A little tiny weeny Duracell battery we got here. It did a great job on that. Good coating. Now I didn't polish this copper up to a high finish. I'm sure if you did, you'd get a much shinier coat. Seems to be that the more higher level of polish surface there is when you start on the bare metal, the better, the shinier the nickel plate is. When it goes on. But again, perfectly acceptable result. Now here's the interesting one. This is 2 bits of mild steel that I brazed together with bronze brazing rod, and again, lovely result. Now I did polish them on the wire wheel, the brass wire wheel, before I started, and yeah, the plate has gone on equally as well on the steel and the braze. So ideal if you've got brazed parts on a steam engine and you want to make them all the same colour. This is obviously the way to do it. Works a treat. And finally the aluminium. Well, it wasn't supposed to work, and I don't really think it's done anything. There is a line you can see, but I don't think there's any deposit on there at all, which is, that's fine. It wasn't supposed to work. You need to do something else to this before you can aluminium, before you can nickel plate it. But I thought as we had it all set up, we'd try it anyway. So there you go. That's our experimentation over with, I think, for now. Very pleased with the results. It's obviously an extremely useful process, and I will be using this a lot in future. Yeah, let's bring the Jensen steam engine back in so you can have a look at that now. It's got all its nickel plated parts on. Well, I think that concludes part 2 of my adventures in nickel plating. Very pleased with the results. It all worked out really well. Actually using it to do something that I needed to nickel plate, was very useful. Actually, I did do 3 other parts of the steam engine which I'd completely forgotten about. I did them off camera because you saw me do the other stuff, so we'll close in on the Jensen and I'll show you the bits that I did. Now what I'd completely forgotten about was that the screw that holds the steam pipe union to the top of the boiler, that was also broke. All the plating had come off that was brass. And of course I did mention it in the video, the crank and the conrod end, the nickel plate had come off both of those, and it did a beautiful job of replating those. So they've come out really nicely. So overall, I think the Jensen is now pretty much looking the way it should look. So everything on it is it's plated in the proper way. So I'm well pleased about that, and I know that I can do that in the future with other American engines that require parts replating. So is that it? Well, actually, I don't think so. While I was doing this, I was thinking it would be quite nice to plate something a bit larger. All of these items are very small, and they great success. But I think I'd quite like to have something a bit larger. Obviously, it's got to fit in my little tank there. But so I was thinking possibly an old tool, maybe something like an old parallel jawed adjustable spanner. Get a small one, strip it down, clean it all up, and then nickel plate it just to see how it goes. So yeah, anyway, that's thoughts for the future. But if I have any requirements to do any further model steam engine nickel plating, then yes, I will do another video to cover that. But for now, I think that'll do. So as always, I hope you've enjoyed the video and hopefully found it useful. And as always, thanks for watching. Cheers.